This is the Chapter 7 Quiz Review Homework Review video. So number 1 gives you an arithmetic sequence with the first 3 terms, 24, 41, and 58. And Part A wants you to find the common difference. So common difference is what's being added every single time. So in this case, we can see that between 24 and 41, you add 17. Between 41 and 58, you add 17. So the common difference is adding 17. Part B wants you to find the 20th term in the sequence. So the first thing I did is I wrote out our explicit formula. So our explicit formula, u sub n is equal to the first term plus the common difference times n minus 1. So for ours, we get u sub n is equal to 24 plus 17 times n minus 1. And now I'm going to plug in 20 because we want u sub 20. We want the 20th term. So if you plug in 20, you get 24 plus 17 times 20 minus 1, and then if you plug that in your calculator, you end up with the 20th term is 347. So the last part, Part C, wants you to find the sum of the first 20 terms. So there's 2 ways you could do this summation. You could use the formula that we talked about in the notes. It's in your formula booklet, which is the sum of the first n terms is n divided by 2, and then the sum of multiplied by the sum of the first and last term. I chose this one because we know the first and the last term, so this is a nice one. So then if you plug everything in, you get 3,710. Or you could do summation on your graphing calculator, in which case you'd plug it in like this, plug it in your calculator, and you'd end up with the same value. So the next one tells us that they're dropping a ball and it bounces up 2 meters the first time, and then every other time after that it bounces up to 85% of the time before. So that would be a geometric sequence with a common ratio of 0.85. This is similar to the ball bounce lab that we did in class. So they want to know what the height of the ball will be on the 7th bounce. Again, I set up our explicit formula. The explicit formula is on your formula booklet. U sub n is equal to u sub 1, the first term, times the common ratio raised to the n minus 1 power. And then I plugged in what we know. U sub n is equal to 2 times 0.85 to the n minus 1. So now I'm going to plug in 7 every time I see an n. So when you plug that in your calculator, you end up with this long thing. And then if you round it to 3 significant figures, you get 0.754 meters. I called this number 2, but it's really number 5 on the actual sheet. It's the second problem that you had to do. So number 7 is the next one that you had to do, and it says that Tomas is training for a 50-kilometer bike race, and he starts off by cycling 5 hours the first week and then wants to increase his training time by 10%. In order to increase your training time by 10%, that actually means that you want to ride 110% of the week before. So your common ratio is actually going to be 1.1 or 1.10, and your first term is 5. So the first question wants us to show that he will cycle for 5.5 hours the second week. So I set up our explicit formula. U sub n is equal to the first term times the common ratio to the n minus 1. So u sub n is equal to 5 times 1.1 to the n minus 1. So now I'm just going to plug in 2 every time I see an n for the second week. And if you plug that in, you end up with 5.5 hours, which is what they wanted. Part B is same thing. They want to figure out how much he's going to cycle in the 5th week. So I'm going to take our explicit formula and plug in 5 every time we see an n. So in this one, you end up with 7.3205, which if you round it to 3 significant figures, would be 7.32 hours. Last question says that he trains for 12 weeks and wants to know what his total training time, so total is going to be sum. So we want to take the sum of the first 12 weeks. So you can do this either by using the sum formula on your formula booklet for a geometric series, or you can use your graphing calculator summation. If you use the formula on your formula booklet, you would have ended up with the sum of the first 12 terms is the first term 5 times 1 minus the common ratio 1.1 raised to the 12th power over 1 minus 1.1. If you had plugged it into the graphing calculator under summation, this is what it would have looked like. In any way, when you round it to 3 significant figures, you should have ended up with 107 hours. So number 9 is talking about a repayment plan. And the first one says that she starts off repaying $450 the first month, and then it reduces by $5 every single month. Part A wants to know how much Francine will repay on the 30th month. I set up my explicit formula. U sub n is equal to first term plus the common difference times n minus 1. So you end up with U sub n is equal to 450 minus 5 times n minus 1. And then if we plug in 30 for the 30th month, she'll pay $305 on the 30th month. Part B wants us to find the total amount she will pay over 3 years. Because our n is in months, we need to switch 3 years into months. 3 years is 36 months, so we're going to let n be 36. We're going to find the sum of the first 36 terms. Again, you can either use the formula on your formula booklet or your graphing calculator. So I used the formula from our formula booklet, and this time I used the n over 2 is equal to 2 times the first term plus the common difference times n minus 1 because I don't actually know what the 36th term is. So then I plugged in 36 for n and negative 5 for d and 450 for u sub 1, ended up with $13,050. You would have ended up with the same thing if you had done it on your graphing calculator. So part 2 wants us to go through the same process, but Bradley started out paying $600 the first month, and his common difference is negative 8. So part A wants us to find the total amount Bradley repaid after 3 years. So we're going to go through the same thing that we did right here in part B of part 1. So I did the same exact thing I did in part B, plugged everything in. You got n is again 36, u sub 1 is now 600, and d is now negative 8. You end up with $16,560, which would have been the same thing if you had used your graphing calculator. Part B wants us to know what month the repayment amount will be the same for Francine and Bradley. So what month are they going to pay the exact same amount? So in order to figure that out, we want to know the amount that Francine is going to pay, which I'm calling here f of n, which is the same as our explicit formula over here in part 1a. And then we want that to equal what Bradley's going to pay, so I called it b sub n, which is our explicit formula down here in part 2a. This should say part A, not part B. So we're going to set the two explicit formulas equal to each other. So I set the two explicit formulas equal to each other. 450 minus 5 times n minus 1 is equal to 600 minus 8 times n minus 1. And then I just simplified this out. Then if you solve for n, you get n to be 51. So on the 51st month, they will pay the same amount. Now we're getting into past paper number 2. So this was a real question from the May 2007 exam. So for part A, they give us a geometric progression or a geometric sequence, G sub 1. That has a first term of 1 and a common ratio of 3. They tell us that the sum of the first n terms is 29,524, and we want to find n. So the sum of the first n terms for a geometric series is u sub 1 times 1 minus r to the n over 1 minus r. So I plugged in 1 for u sub 1 and 3 for r, and set that it's equal to 29,524. So now we're going to use the graphing calculator. Go into y equals, y sub 1, I simplified this to negative 1/2 or negative 0.5, 1 minus 3 to the x. Y sub 2 would be 29,524. Adjust your window. I would say x min 0, x max to be 15, y min to be 29,500, and y max to be 29,550. You just need to be able to see this y coordinate. Then go to second trace, hit 5 or scroll down to intersect. Use your left and right hand arrow keys, your cursor keys to move to the intersection. Move your cursor to the intersection point and then hit enter 3 times. When you do that, you end up that n is equal to 10. For part B, they give us a second geometric progression, G sub 2, or a second geometric sequence, 1, 1/3, 1/9, 1/27, so on and so forth. And they want us to find the common ratio, so every single time you're multiplying by 1/3. We don't say divide by 3, we always say multiply by 1/3. Part C wants us to find the sum of the first 10 terms. So again, we're going to set up our summation equation for geometric sequences. So whichever way you do that, whether you use the summation formula or you use your graphing calculator, make sure you put parentheses around 1/3. That way it raises both of this to the 10th power. In either way, when you round to 3 significant figures, you should end up with 1.5. So then part D says why, when you go to 1,000 figures, or excuse me, 1,000 terms, would you also get 1.50 to 3 significant figures. So your numbers are going to get smaller and smaller, and they're going to get so small that it's going to be kind of insignificant. So it's going to end up being the same value when you end up rounding to 3 significant figures. Part E takes a little bit of thought. So they give us this new sequence: 2, 3 1/3, 9 1/9, 27 over 20, and then 1 27th. And right away, it's not obvious what the pattern is. You have to know what this kind of means. So even though we write them next to each other, it's not actually 3 times 1/3. It's actually 3 plus 1/3. So your sequence ends up being 1 plus 1, 3 plus 1/3, 9 plus 1/9, and 27 plus 1/27, so on and so forth. So if you actually look at this closely, you have 2 parts. You have the first part, which starts at 1 and multiplies by 3 every time, which was G sub 1, our first sequence. And then we have the second part, which starts at 1 and multiplies by 1/3 every time, which was G sub 2, our second sequence. So this is really our first sequence plus our second sequence. So if they want the sum of the first 10 terms, then we can actually find the sum of the first 10 terms by adding our sum of the first 10 terms of the first sequence and our sum of the first 10 terms of the second sequence. If you want an explicit formula to plug it in your calculator, this would be 3 to the n minus 1 plus 1/3 to the n minus 1, because you took the first explicit formula and added the second explicit formula. But if you just add these two sums, you end up with 29,525.5. So past paper number 2 starts out with an arithmetic sequence that has a first term of 0 and a common difference of 12, and it asks us what the 96th term is. So I set up an explicit formula. U sub n is equal to first term 0 plus common difference 12 times n minus 1, and then plugged in 96 for n, and you end up with 1,140. The second part gives us a geometric sequence that has a first term of 6. I called this W instead of U just to separate the two of them. And then it tells us that the 6th term is the same as the 17th term from the arithmetic sequence. So W sub 6 is the same as U sub 17, so this one up here. So I plugged in 17 into U sub n, and I got 192. So the 6th term in the geometric series is 192. Part B says write down an equation using this information. Looking at part C, I know they want us to find the common ratio, so I'm going to set up an explicit formula. So if we set up an explicit formula for a geometric sequence, you get W sub n is equal to W sub 1 times r to the n minus 1. Again, I'm just using W because I want to differentiate between these two sequences. So then if we plug in what we know that the first term is 6, but we don't know r. So I'm going to write a little bit more. I'm going to use this fact that we know that W sub 6 is 192 to kind of complete this equation. I have 192 is equal to 6 times r to the 5th. Now I only have one unknown instead of both not knowing n and not knowing r, because part C wants us to actually calculate this. So there's a couple ways you could do it. You could plug in 192 as y sub 2 and 6 times r to the 5th as y sub 1 and do your intersection on your graphing calculator. Or you could just solve this algebraically. So if you divide both sides by 6, you get 32 is equal to r to the 5th, which I know 2 to the 5th power is 32, so that means r must be 2. You could have also taken the 5th root of both sides. So this has been the review video for the Chapter 7 quiz.